In this video, we're going to go through Unit 8, Assignment 3, the first part. We'll be covering number 2, 5, and 7. So for number 2, the first thing we need to do is balance this equation. So this equation looks kind of complicated to balance, but I know y'all can do it. We're going to start by balancing our carbons. So I'm going to start by just making a balancing chart. So on my reactant side, I currently have 7 carbons. And on my product side, I only have 1 carbon. On my reactant side, I currently have 8 hydrogens. And on my product side, I have 2. And I have 2 oxygens on my reactant side and 3 oxygens on my product side. Don't forget, there's 2 oxygens here plus 1 oxygen from H2O. So I'm going to start with my carbons. I have more on my reactant side, so I need to add a coefficient on my product side. And to get it to 7, I'm going to add a 7 there. So now I have 7 carbons on both sides. So yay, that one's balanced right now. And then same with my hydrogens. I have more on my reactant side than my product side. I have 8 on my reactant side, so I need to get 8 on my product side. So something times 2 needs to give me 8. Well, that's going to be 4. So 4 times 2 will give me 8 hydrogens. So my hydrogens are balanced, but that 4 also changes the oxygen. So this would mean I have 4 oxygens plus, and this would mean I have 14 oxygens. So I really have 18 oxygens on my product side. So how do I get 18 oxygens on my reactant side? Well, if I have 2 oxygens here, something times 2 has to give me 18. So I'll need a 9 there. 9 times 2 would give me 18 oxygens. And now my oxygens are balanced. So everything is balanced. So that's great. The question for 2 says, what is the mole ratio of C7H8 and CO2? So I am looking at my mole ratio of C7H8 to CO2. So the mole ratio is indicated by the coefficient of the balanced equation. So my mole ratio in this case is 1 to 7. For every 1 mole of C7H8, because even though this is blank, that really just means the coefficient is 1, I need 7 moles of CO2, or I will produce 7 moles of CO2. Question 5 says, how many moles of carbon dioxide will be produced from 17.4 moles of C7H8? So I just copied the reaction from the previous slide. We're still using this reaction. We are looking at the relationship between carbon dioxide and C7H8 again. So I want to know how many moles of carbon dioxide, so that's my unknown, will be produced from 17.4 moles of C7H8. So that's my given. So what I'm going to do is I'm going to start with my 17.4 moles of C7H8. Now I need to convert from C7H8 to carbon dioxide. Well, I know that 1 mole of C7H8 is equal to 7 moles of carbon dioxide, or can produce 7 moles of carbon dioxide. So 1 mole of C7H8 can produce 7 moles of carbon dioxide. So I'm going to use that as my conversion factor. I am getting rid of moles of C7H8. I am using them to convert into moles of carbon dioxide. So 7 moles of carbon dioxide is equal to 1 mole of C7H8, or can be produced by 1 mole of C7H8. So my moles of C7H8 cancel out, and I'll be left with my mole of carbon dioxide. Then I just need to multiply by my numerators, and this is like over 1, and divide by my denominators. I get 121.8. But notice there are 3 significant figures that are given, so I'm going to round this to 122 moles of CO2. So that's my final answer. Lastly, we're going to do number 7. The first thing I need to do is balance this equation. So I'm going to make my balancing chart again. On my reactant side, I have 2 hydrogens. And on my product side, I also have 2 hydrogens. And on my reactant side, I have 1 plus 2, so that gives me 3 oxygens. And on my product side, so that's my reactant side, and on my product side, I have 2 oxygens. So the only thing that's not balanced is my oxygens. So I'm going to start by noticing that there has to be an even amount of oxygens on my product side. But I have an odd amount on my reactant side, and that's because there's only 1 oxygen in H2O. So I'm going to start by putting a 2 there. Well, that changes my hydrogen. Now I have 4 hydrogen, and I have 2 oxygens plus these 2 oxygens. So that gives me 4 oxygens. And then on my product side, I still have 2 hydrogens and 2 oxygens, but if I put a 2 here, now I would have 4 hydrogens, so that would be balanced, and I would have 4 oxygens, so that would be balanced. So now the question is, how many moles of water are needed to produce 21.9 moles of hydrogen peroxide? So I am looking for moles of water, that's my unknown, and I am given moles of hydrogen peroxide. So I'm going to start with my given. So that's 21.9 moles of hydrogen peroxide. And now I'm going to convert it into water. So I need my moles of H2O2, hydrogen peroxide on the bottom, and moles of water on top. I'm canceling out my moles of H2O2 and converting into moles of water. And remember, this is like over 1. So I need to look at my balanced equation and say, okay, I need water to hydrogen peroxide. Well, notice 2 moles of hydrogen peroxide are produced from 2 moles of water. So my ratio is 2 to 2, which you all know is 1. So my answer is going to be 21.9 moles of H2O. So if I have 21.9 moles of H2O, then it can produce 21.9 moles of H2O2. So that's my answer.